Good morning. My name is Robin Jane. I represent a company called Logtra Solutions. We became involved in the SATCAP in terms of the Rockdrill Marking Augmented Reality project to be able to be here with you today to do the exhibition for 2022 to show you the training approach. We are contracted via the CSIR, who's doing this project on behalf of the Mandela Mining Precinct. And our role was literally to go and have a look at putting together the standard operating procedure for how augmented reality for rockdrill operators would work, and then to be able to put together a small video clip to explain the concept to you. So when we started, we started with looking at the training system. How would the augmented reality solution fit into how we are going to train rockdrill operators? So the first thing we identified was we need a standard operating procedure, which you can see here on the left of the screen. We decided we needed to be able to give them some procedure that explains to them what augmented reality is, what the tools associated with augmented reality are, and how they would be able to use it. So we put together an SOP for them. This is really a generic SOP that any mine can then take, customize it to their own layout for procedures and use the terminology that they're using and be able to put together something to be able to use the AR solution. This SOP was made on a specification that we agreed upon with the CSIR in terms of what its look and feel looks like. And there you can see just what the cover of the SOP looks like. We're going to talk about the SOP a little bit later. So when I say SOP, we're talking about the approved procedures which prescribe the processes, methods, etc. for using AR in marking. This SOP would then come to the formal trainer who's already working on the mine, which is this guy that you can see here. He will use that SOP to be able to give just-in-time training to the rockdrill operator. When we say just-in-time, we mean that he doesn't really need much formal education on this besides which he already knows, taking the SOP, taking the AR solution, and just being shown how it fits together to make his life easier. So this trainer essentially in class will be using this SOP, and then he will have a tablet of sorts. We're using an iPad for the sake of the demonstration. And you can see on this iPad, we've just given you 3 specific tools that we will be making use of. The first one, the SOP. So he will have the SOP digitally available on this tablet that he can look at, refer to wherever he is and with whatever he's doing in case he needs to refresh himself about the use of something or troubleshooting or things like that. The second tool that you'll find on his tablet is this little animated video clip here, which we've made bigger for you here, which is the animated video clip that will show him how the procedures work, what the concepts are, and how it will all fit together to be able to work. The third tool that we're giving you is this little green app button here, where you will then be able to see this on the screen, where it's actually showing you the drill pattern and where the holes must go in terms of using the app. And we'll get to a demonstration of what that looks like in a moment. So now I'm going to talk a little bit more about the SOP, just in terms of why do we actually need the SOP? So the SOP, as you can see written on the screen there, is to ensure that the trainer, the miner, and the supervisor and other role players all understand the process of using the AR solution when doing rock face marking, and to be able to ensure that they can correctly and safely operate the equipment within the mine. Bringing this AR technology into rock face marking allows us the opportunity to use the technology for both training purposes, which we're discussing now, but also for operations and also for compliance. We'll talk a little bit about compliance later. If you look at the figure on the screen, you'll be able to see how we've broken down the SOP into its relevant sections. So the first part is the green part up here, where the SOP will speak to a process and an overview, just to give you an idea of what augmented reality is and how we see the solution fitting into the mining environment. The second part of the SOP, which is this blue part over here, addresses what equipment requirements are required to be able to make sure that the solution is able to function in the mining environment. The third part is the setup instructions. So how would you set up the AR solution in terms of what is required to be able to make sure everything is in place to make sure it works? The next piece we deal with is how to attach the AR target. The AR target is literally a symbol that is required to allow the device to realize that augmented reality must now start working and it gets the app functioning. So we will teach you how do you do that alignment and how do you attach the target. The next part is how do you use the app on the tablet. Now, we are not going to control what tablet you've got. Like I said, we're going to be using an iPad for the demonstration purposes, but you could have any tablet. So the idea here would just be able to tell you what functioning that tablet must have, but not necessarily speak to exactly how that tablet works. The last, or the second last part that we're going to deal with is how do you actually then go about marking the rock face and recording how you've marked it. And the last piece is any troubleshooting that you might have in terms of problems either with the pattern on the face or the use of the app or Wi-Fi connectivity or anything like that that we've thought of in terms of what problems you might experience. We will address them here. The idea behind the SOP is then that we'll be able to provide this SOP both as a printed hard copy document, but also as an electronic PDF file that can be loaded onto the tablet or other devices. If you recall the training system slide, we showed you that all of these SOPs would be able to be on that tablet and available to the RDO when he is actually doing the work in the mine. And that's how we say this SOP can be used for operations down here at the bottom to be able to make sure they know just in time problem solving or setup instructions or operating instructions while they're actually marking the rock face. So now I'd like to use the standard operating procedure just to orientate you in terms of the procedure, but also to introduce some of the equipment and processes that we'll be using AR solution to rock face marking. So here you can see the cover. I'm going to take you to the table of contents and I'm going to make this slightly bigger for you. Now you can have a look. So you'll see here is the key things that we address in the SOP in terms of making sure we're giving the miner, the rock drill operator, and everybody else that's going to be involved with this process the information that they need to be able to do it successfully. So you'll see we start off by providing them a very simple process overview that shows them the steps of how to do it. We then discuss on how do they make sure the face is ready for marking, the equipment, how to use the equipment, how to move with the equipment, and then the other more AR specific type things like how to attach the target to determine the set out point, how to use the tablet, and then eventually finally how to mark the face and maybe communicate with an engineer or somebody else if you need to send some information to them. So this just gives you an overview of what is inside the SOP. I would now like to take you to this page where, if I make this slightly bigger for you, we can introduce you to the process. So here you can see it's a really, really simple process. And remember, we're only looking at the marking of the face, nothing else. We're looking at how can we use augmented reality to mark the face. There are far more applications for AR than we are trying to address here. And I think we don't even know all of the applications that we could possibly do with AR. But for now, all we're looking at is marking the face. So there you can see a small process flow diagram that shows you the steps the miner will go through in terms of using the AR solution to mark the face. The next key thing you need to understand is these three pieces of equipment. These three pieces of equipment are essential to making sure the AR solution will be able to work. So the first one you should be familiar with now, it's the tablet. Again, in our case, we're using an iPad. The second one that we're using is this one here. This is the AR target. The AR target is used so when the device is pointed at the target, the device realizes that you're looking for an augmented reality world and it switches on that world for you so that the device shows you what you need to see. The third piece of equipment is something that we're going to introduce to you for the first time now, and this is the Wi-Fi extender that is used to be able to make sure there is network coverage inside the mine underground where the miner is working. Specific piece of equipment. Here you can see a better indication of the network extender. This specific piece of equipment was originally developed for military use to be able to work underground to make sure that the soldiers had communications and that their command and control structures worked. The Artemis program took this technology and started to apply it in a mining environment to be able to make sure that we now have the ability to extend the Wi-Fi network underground. This device is very simply made to be able to have a hook, which you can see here, to allow it to be hooked onto literally anything inside the mine. Maybe a roof bolt or piping or anything that's inside the tunnel or area where the miner is working where there is no reception. The next part that you need to understand about this device is these two little lights that are down here. The one is a green light and the other one is a red light. So as long as the Wi-Fi extender is receiving signal, the light will be green. The light will go red when the miner moves too far from the signal and it loses the signal, then the red light will illuminate. So all the miner has to do is make sure as he moves towards the rock face that he connects these inside the tunnel and that their lights are green. These devices create what is known as a mesh network. So it's not a linear network where if one fails, the entire network will fail. It creates a mesh network that all of these devices speak to each other. So if one should fail, there should be a mesh already around it, if we can call it that, that will make sure that the network stays stable and that the communication channel remains open. That concludes what I want to tell you inside SOP. We are now going to show you a short animated clip to explain the concept.
Molweni, igama lam ngubongani. Ndiyanamkela kwi-SATCAP Augmented Reality Process Animation. The purpose of this animation is to give you a better understanding of how the augmented reality process works. Step 1. Collection of equipment. Collect the following items at the start of your shift. These items will form a part of the augmented reality equipment set. 1. Collect a charged headlight in order to see the face more clearly and provide sufficient light for the augmented reality application to function properly. 2. A charged tablet, preloaded with the augmented reality application, which is Vuforia. 3. A charged network extender device. The purpose of this device is to extend the range of the mine's Wi-Fi network. Finally, remember to also collect the augmented reality target. The target is to be placed on the face, making it possible for the augmented reality application to locate the information and display it on the tablet. Step 2. Enter the mine. Enter the mine by means of protocol from the assembly point, then travel towards the planned route with the collected augmented reality equipment. Step 3. Build the mesh network. From this point, we will build the mesh network with the provided network extenders. Very important. While traveling in the direction towards the face, extend the network by placing network extenders along the way. Keep an eye out for the red or green lights on the network extender in your hand. Should the network extender's light switch from green to red, it means that it is out of range. If the light turns red, stop and walk back into the green zone and place the network extender at an appropriate prepared place against the wall. This process is repeated until you reach the face. Step 4. Assessment of the face. Before all else, place the AR target onto the set-out point on the face, which will be directly underneath the intersection of the survey and the grade line. You can also see the center line displayed on your screen. Switch on the tablet and make sure that the Wi-Fi connection, which is established via the previous step. Open the Vuforia app on the tablet and point the tablet sensor at the AR target that was previously placed on the face. The AR app will now automatically recognize the target on the face. After the AR app has recognized the AR target, the AR app then prompts the user to log in via a username and a password. Tap on the rock drill operator button to continue. You will now see that the AR app starts with the assessment of the procedure, where the responsible person can then view the alignment of the physical face compared to the theoretical face on the AR app. The operator is free to select the appropriate drill pattern. Step 5. Marking of the face. The AR app will now move to the marking procedure. With the help of an assistant, the face can now be marked where the AR rod intersects with the face in real time. Contingency. Should you be uncertain of the drill pattern, you can take a photo of the deviation via the built-in photo functionality of the AR app, which will be automatically sent to the engineer or supervisor for remediation. The engineer or even the supervisor can then reply with exact instructions via the AR app on how to address the deviation. Now, should it happen that the responsible person is still uncertain of the solution for any reason, he or she can phone the engineer or the supervisor using any form of communication that functions on the network. Then you can apply that proposed solution from the engineer or the supervisor. Step 6, drilling of the face. The AR app will now move on to the drill procedure. The operator can now drill the holes in accordance with the marked face. Step 7, proof of work. The AR app will now move on to the proof of work procedure. The AR app now will display virtual marks in accordance with the drilled holes on the face. Check that the holes align with the virtual marks in the app. Lastly, tap the capture proof button in order to initiate the countdown. The AR app will automatically submit the proof of work to the relevant engineer or supervisor. Thank you kindly for taking part in this entire process with us.
As part of the project, we were asked to have a look at how would AR impact the Mining Qualifications Authority and the existing qualifications and the way they are taught. So one of the key things that we looked at when we discussed AR was how is it going to impact the notional training hours? And it doesn't really impact the notional training hours. What it does impact is how we can split those notional training hours. So AR solutions will allow us more time for practical and work experience components and less on the knowledge, which should be key in this environment, making sure that the miner or the rock drill operator is able to perform according to standard. The second key thing that we looked at is the current qualification is very heavy on operating the drill and doesn't focus as much as it possibly could on methods and processes. AR gives us the opportunity to add methods and processes to the qualification. Finally, we asked questions about how can AR be used to support training on the other equipment or the drill. And lastly, we looked at how can AR be used to assist assessment. We believe AR can play a large role in assisting with the assessment. In closing, I'd like to speak about how the entire system comes together in the end, of how AR solutions can be more than just the solution that we're talking about in this presentation with regards to rock face marking. We will be able to have a system where we can have the existing mining qualifications that you'll see depicted on the left here, the existing mining qualifications or 2B qualifications that then speak to standard operating procedures in any mine. So the SOP that we've made now is truly a generic SOP that can be customized by the mine to suit its template, its layout, its naming conventions, whatever it's using, but to provide a generic SOP that can be customized and then used for augmented reality in the mine. That SOP then comes across to our traditional trainer that can now make use of a blended solution where they can do the normal classroom training in terms of rock face marking. They are then able to blend that with augmented reality scenarios where we can add our little virtual trainer that you can see that we placed on the tablet now that you met during the video clip, and all other training solutions that we can put inside a tablet. Remember, this tablet stays a tablet. What we mean by that is the capabilities that come inherently inside this tablet are available to the miner. So like you saw on the video clip, the tablet can be used to take a photograph, to be able to record a rock face. It can be part of record keeping. It can be part of data gathering and eventually data analysis in terms of what trends do we see on rock faces based on the photos that we now have in terms of a library that's created. Inside that tablet, we could also have, like we discussed earlier with having our SOP there could be a whole library of SOPs. So all the SOPs that the miner needs to have, you can now have digitally available underground for quick reference when confronted with a situation that he needs to address. The tablet also provides us the various applications that we can use. So there will be communication applications such as WhatsApp, where you could send voice or you could send data or you could even send further images. The app that we're currently using for AR has the ability to send the image like you saw on the video clip, and you can do screen captures if you want to record how the drill pattern was put together. So the device brings the fourth industrial revolution to the miner underground. The final question we want to leave you with is, this project only looked at rock face marking, but what other applications are there for augmented reality in the mining community? One that we've seen that is a possibility is using augmented reality for training on the drill, the functioning of the drill, the naming of the components of the drill, and troubleshooting. So the application of AR in the mining environment is endless. One needs to apply your mind to be able to see where and how it can work. Thank you.
This project was brought to us originally via the CSR and is referred to as SATCAP Work Package 4. And Work Package 4 examines how mining, drilling, markup can be modernized and improved in the underground conventional mining arena. The SATCAP 4 looks at three things in particular. One is the actual markup of the mined faces to be drilled. Secondly is the training of the rock drill operators and how augmented reality can be used in enhancing training. And thirdly, how communication systems can be used to communicate between the rock face underground, the man facing the immediate daily challenge, and the rock engineer or other technical person on surface. The scope of our works and what we are presenting today is to look at the former, and that's the use of augmented reality in the markup of the drill face.
So augmented reality is all about visualizing digital information in the physical world. This enhances our understanding of what's really going on in the physical world. In this case, we're visualizing exactly where the drill holes need to be drilled, and we're doing this off of the standard design. In this case, we're using augmented reality via an iPad. So the iPad is looking at the physical world through its camera, while I'm then looking at the screen and then seeing the digital content overlaid on top of the physical world.
Augmented reality can be used right across the underground mining industry, but we are obviously looking at face markup, and markup is required in all aspects where drilling is involved. And we've chosen to look at of a typical development end, a crosscut, and that's an end that's 3 meters wide and 3.5 meters high, and used a typical drilling, markup and blasting approach. We are not using a specific mine standard, we're more using a typical approach so that each mine that operates using these mining standards can adapt the augmented reality to suit their standards and their needs. So this crosscut, we'll look at the markup of the crosscut, the profile, the drilling before and after, the charge up, and then the blasting sequence.
Communications underground could be quite difficult. Part of the RTIM's research is to understand how we can use voice, data, and video underground, communicating from the device at the face back to surface. We're using an augmented reality target on the face at the setup point. The augmented reality target is important for the iPad to know exactly where the digital information needs to be placed in the real world. So in this case, we're using a thing mark. The thing mark, as you can see on it, has a code around the border which identifies the exact location that we're at, and it also provides the tablet information for exactly where the digital information should be placed in the real world. When a rock drill operator arrives on site at the face, the target should already be installed for him. What he would then do is approach the target with his iPad and scan it using the application provided. In this case, we're using Vuforia View. He'll scan the target, the application will launch, and then he'll get into the augmented reality experience. Okay, so the RDO would arrive at the face with the target already installed. They would launch the app and just scan the target. The application will load up the experience that he needs to use, and in this case he's using the underground experience. He's then prompted again to scan the target, and this is to align the tracking of the digital world onto the physical world. So there you can see the application's locked on to the target, and now we can actually visualize where those grade lines, center lines, and survey lines are to make sure they correspond with the physical, well, the lines that have been painted in the real world already. Okay, at the next stage, he's able to visualize what's happening with the future infrastructure. This allows him to see what obstacles there might be in the way for things like the rail tracks, the drain. If I turn on the labels here, we can actually see what those things are called. What's in the way of the walkway? Is there space around the ventilation? Does it have enough clearance? The water columns and the other piping that's required. Okay, at this stage, we're looking at marking up the face. So again, it's important to make sure that the grade lines and center lines still correspond with where the physical lines are painted. What the RDO would then do is approach the wall, find out where the end of the green rod intersects the wall, and make a mark at that point using spray or some other method. He can also visualize the grid lines, which is the more traditional way that these faces are painted. And he can also visualize what each of these different types of holes are called. So we've got the cut holes in the center, we've still got our survey, grade, and center lines, and then we've got our pilot holes at each corner. So your pilot holes might vary from mine to mine, how you drill them. They're marked out in a different color, which makes it easy to understand which ones are the pilot holes and at what angle should they be drilled. We can also visualize dimensions, so we can verify and validate that we have actually spaced these points at the correct distance apart. On this view, we've got the drill rods. The drill rods are very much similar to the markers that we were showing on the previous screen. But in this case, what we can actually use them for is aligning the actual drill bit with these rods to make sure that the drill is done at the correct angle. Once the drill holes have been drilled, the RDO can capture proof of their work. So as you can see here, we've got these yellow rings with like a crosshair in the center of them. That would indicate where the ideal placement of the drill hole should have been. And they can then capture that, take a photo of it, to check and send that up to surface to show where they drilled compared to where it should have been drilled. Okay, on the last view, we can look at the blast sequence. So we can have a look at the pattern and the timing. So we can see here the burn holes and the stab holes indicated with the different triangles. And then we've got the face holes and the pilot holes around the perimeter. We can also view the timing sequence and order in this table. And we can also bring up some dimensions if we need to check something. Then we can also visualize the actual sequence and order that this is played in and get an understanding for how quickly this blast happens. And this is happening at the same time as as the timing table indicates. Okay, so we're going to mark off where this hole needs to be drilled. So where it intersects with that green rod. So it's sitting over there. Let's mark off the next one below it. So we check where does this green rod intersect the face. And that's over there. Let's take this marker here. And perhaps he places it a bit off center. We'll check how that accuracy is indicated in another screen. Okay, and we place another one there. Okay, and we can compare where the actual drill holes were made compared to where they should have been made. So in this case, you can see these ones here were pretty accurate, whereas this one here wasn't. That could be caused, or maybe he wasn't able to drill at a specific place due to a certain imperfection in the face. And so that is what where he had to make that drill. Okay, so imagine I'm the RDO at the face and I'm needing to capture the proof of work. All I would need to do is take a photo of that proof of work, and that will then be submitted to the surface.
And in this case, imagine that I'm a rock engineer or a surface technical person who is needing to discuss a particular problem with an underground RDO or mining man. The mining man can simply take the photograph and send it, as just shown now, and I would then receive it here and have a record of what has just been shot underground. So effectively, in just off real time, I'm able to see precisely what is happening with the drill mock-up, and in fact the face profile. It is unlikely that a mining man needs to speak to an expert about a drill hole being a few millimeters off perfect, but in reality there could be geological features, overbreak, underbreak, or other difficulties that could be consulted with in real time.
The advancing tides of technology powerfully shape the world we know, a man-made force of nature. The consequence of underestimating its power and influence leaves us fighting against the currents of change. However, harnessing it puts the future in our hands. That is the art of the possible in mining. The SIMERDI's successful application of technology centered around people, or SATCAP, Work Package 4 research program led by the CSIR set out to explore the benefits of integrating 4IR technology with education in the mining sector, demonstrating the art of the possible through developing an augmented reality solution to upskill and support rock drill operators and miners for gold and platinum group metal mines. Due to the modernization of mines, the role of traditional training needs to be reassessed in relation to modernized training approaches. The research proposal dealt with this topic in detail and showed that not only was there a need to reassess training in mines, but there would also be massive benefits in doing so. The data collected led to the exploration of concepts that make up the augmented reality experience. We explored how AR combined with underground communication technology as used by the military allows for new technology to modernize the marking of drill holes at the rock face, and how we could integrate it with mine operators in a seamless manner. Interestingly, significant improvements have been devoted to processes to ensure effective drilling and blasting, but surprisingly, little has changed for the marking of drill holes. Mining is still relying on the traditional and conventional way of marking holes. Improving the marking of drill holes aligns to the Minerals Council's initiatives such as the Isidingo Drill Design Challenge, providing faster and more precise drilling that could reduce safety incidents such as falls of ground. Additionally, lowering the cost of ownership of the equipment and creating and defining new jobs. The augmented reality idea stemmed from a practicum station within the Learning Factory laboratory at the CSIR manufacturing cluster. AR tools allow miners to walk freely up the rock face and maneuver a tablet to show the applicable drill hole positions according to the pattern. It then enables the rock drill operator or miner to mark the relevant holes. The consideration of drill hole placement is critical to achieve 1. Safer hanging wall conditions. 2. Reducing sockets. 3. Improved turnaround time. 4. More efficient fragmentation. 5. Straight face, good marking. And 6. An overall ease of use. It was noted during the study that training is moving away from traditional isolated classroom-based training. Hands-on experience is necessary, and the need for a simulated environment is a massive advantage. This takes the form of readily available training at the operational workplace. In addition, training should form part of a holistic approach. Connectivity makes it possible to integrate a wide array of equipment, technology, and operating procedures. Adopting the art of possibilities introduces practical and tangible opportunities to take advantage of augmented reality in conjunction with real-time communication and just-in-time learning. Blended AR training with classroom learning is shown to be the most effective and accessible way to effectively upskill and reskill miners. A just-in-time approach means access to any training is available when and as needed. The future of training is not locked away in a classroom. It's opening a class to a world of tangible, fast, and accessible learning. If technology is a force of nature, then the art of the possible is the key to unlocking its potential.